angles, right? We filled out pi over 4, which is 45 degrees, but now we are looking at 30 degrees and 60 degrees. So we can finish up the chart. Okay, so let's look at unit circle again. And I divide these in 3. This 90 degrees, first quadrant, in 3. So this is the 30 degrees, or pi over 6. I know that this piece between the center of the circle and this corner, between this piece and this piece, what is this measure going to give us? This piece. When I measure between this point and this point, what will this give us? What do we measure on the x-axis? Excellent. Thank you. So this must be cosine alpha. Perfect. And then what will this piece measure from this point on the circle till this point? Yes. Very good. So now our alpha is pi over 6, or 30 degrees. What do we know about a triangle in which, a right triangle in which one angle is 30 degrees? What do we know about the opposite side? This is a result from geometry. It comes from Trig, actually. Well, what is the radius? What is the length of this? 1. Well, the leg that is opposite to a 30-degree angle in a 30, 60, 90 degree right triangle only is half of the hypotenuse. Only in a 30, 60, this is 60, in a 30, 60, 90 degree right triangle, the leg opposite to the 30-degree angle measures, that's always measures, half of the hypotenuse. If that's the case, how much is sine 30 forever? Exactly, 1/2. I don't know cosine yet, but I do know that in this right triangle, this is 1 and this is 1/2. Am I capable of finding the other leg? The answer is yes. So I'm going to call it x. And I'm going to say that x must be the square root of 1 squared minus 1/2 squared. A leg squared is also always the square root of the hypotenuse squared minus the other leg squared, correct? Okay, how much is 1/2 squared?
1/4.
Exactly, very good. So x equals the square root of 1 minus 1/4. From $1, I subtract 1/4. What do I get? I get the square root of?
3/4.
Yes. I have to take the square root from the top, which I cannot, and then I have to take the square root from the bottom, which I can. So then, can anyone tell us how much is cosine 30 degrees? Of course. So coming back to our chart, I forgot to keep that page. Sorry about that. So I'm just going to write the angle alpha, sine, cosine, tangent, cotangent, secant, and cosecant. And what I don't have is 30 degrees or pi over 6 and 60 degrees or pi over 3. Okay, So you already told me sine 30 is, and we cannot ever forget this. Sine 30. 1/2. And cosine? Yes. Perfect. Now I have to calculate the tangent. So it will be 1/2, right? Tangent 30 degrees over the square root of 3 over 2. I copy the top. I flip the bottom. And I get 1 over the square root of 3, but we don't like the radicals in the denominator. I rationalize with the square root of 3, and I get this. Now I'm trying to find cotangent of 30 degrees. I will look at this. I will flip this, not that. So when I flip this, square root of 3. Now secant. Secant is 1 over cosine. So I have to flip this. But when I flip 2 over the square root of 3, I have to rationalize it. To the square root of 3 over 3. And cosecant is 1 over, yes. Questions on this? Questions? Okay. So we have now to talk about 60 degrees. So let's come back here. So let's see what happens with 60 degrees. This becomes 60, and this becomes 30. How much will this be if this is now 30? Yes. How much will this be? The other one. Right. So the square root of 3 over 2 and 1/2. Tangent and cotangent will be reversed. Secant and cosecant will be reversed. From all of that chart, here's what I want you to remember. Right? Did you fill it in? Is it complete now? All of it? Okay. Here's what I want you to remember, and nothing else. No. 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 No, not even that, because you have no problem with those corners. Okay, no. Then you just draw the unit circle on the side of your piece of paper, and you know exactly what's going on. Those I'm not even going to bother with at all. So angle, sine, cosine, pi over 6, pi over 4, pi over 3. And you can write this on every test from now on if you know it's on trig. That's all I want you to write. 1/2, 1/2. The square root of 3 over 2. The square root of 3 over 2. And what do I write in the middle? Exactly. This is the only angle that has the same sine and cosine. That's all I want you to remember. 3 numbers. 1/2, the square root of 3 over 2, and the square root of 2 over 2. Do not bother with anything else. You don't need to memorize tangent, cotangent, secant. Nothing about those. Why? For example, if I ask you find tangent of pi over 3, you will say I have no clue, and I'll give you a minute. You will say sine pi over 3 over cosine pi over 3, but you have to know that sine pi over 3 is the square root of 3 over 2. And you have to know that cosine pi over 3 is 1/2, and your answer will be the square root of 3, and you're done. Do not bother with memorizing any of that. There's no need. But you have to remember what tangent is, how to find tangent. You have to remember what cosecant is. It's 1 over sine. You have to remember the relationships between those trig functions. But you don't have to sit there and memorize the square root of 3 over 3 and 2 the square root of 3 over 3. No, no, no. None of that. That's all you need to remember. from that chart, nothing else. What about the endpoints, like 0, pi over 2, 3 pi over 2, and 2 pi, and pi? Those you have to remember. Because you know that this one is 1, 0. So cosine is 1, sine is 0. You know that this one is 0, 1. Cosine is 0, sine is 1. And then for all those points, you can determine tangent, cotangent, secant, cosecant. So this is all I'm asking you to remember. 3 numbers, 1, 2, 3. Okay? So now finally I'm getting to what Chris was asking. Okay. So let's go back to our unit circle. I'm going to draw an angle. Of course, the right triangle corresponding to that angle. This is 1. Is that clear? You said something, Shane?
Yeah, so since you explained 30-degree triangle, that makes sense.
For the other one, you mean?
Yeah, because it, like...
Yeah, you just reverse it. Yeah. Okay, so I need one more time someone to tell me what is the length between this and this. The angle is alpha. What is this? This measure. Excellent. And I also need this measure. Yes. Good. So I have in a right triangle, I have the hypotenuse, which is 1. I have one leg, which is cosine alpha. And I have the other leg that is sine alpha. Can you please tell me apply the Pythagorean theorem in this triangle? I'm ready. We don't have any angle. The angle is alpha. We don't know how much it is.
Cosine of alpha plus sine of alpha. Oh, cosine alpha squared plus
yes.
sine of alpha squared.
Very good. Sine alpha squared plus cosine alpha squared. If we say sine squared of alpha and cosine squared of alpha equals?
Oh, 1.
That's it. This is one of the most important trig identities. And of course, you're clear that there has to be the same angle, right? I cannot say the sine squared of 45 degrees plus sine squared of 60 degrees is 1. No. So this has to be the same angle, right? We only have one angle here. Central angle. Good. Sine squared plus cosine squared equals 1. And now I'm ready to come back to what Chris was asking. He said, let's look at cosine squared, 30 degrees, and minus sine squared 30 degrees. I didn't have to put it in parentheses. I put the power next to cosine.
So would that just be like square root of 3 over 2 and 1/2?
Yes, but squared.
Squared,
Yes, yes. So we do have that. I wanted to finish up the table before talking about it. So we know that cosine 30 degrees, and now we have to remember that. Cosine 30 degrees is the square root of 3 over 2. So remember, for the first angle, always start with 1/2. For the smallest angle, you always start with 1/2. And cosine is the square root of 3 over 2. For the largest angle from these three, among these three, you always start with the square root of 3 over 2, and you end up with 1/2, exactly reversed. Okay? Is that clear? Okay, so then I know cosine 30 is the square root of 3 over 2, and I have to square that. And I know that sine 30 is 1/2, and I have to square that. So I get 3 over 4 minus 1 over 4, which is 2 over 4, which is 1/2. So it wasn't negative, Chris. It could be, but it wasn't. That's okay. Yes.
You find the square root of that? Of the 1/2? Aren't you getting? Oh no, it's just. You're not
2 over 4. 3 over 4 minus 1 over 4 is 2 over 4. 2 over 4 simplified.
You
by
don't find the square root of it?
No, this is why I'm asked to calculate this. I'm not asked to do anything else. I'm asked to perform that calculation. Okay, so back to our syllabus for a second, just to make sure that we know where we are. I had to print out another one because I gave one to my colleague who was here a couple of weeks ago, and I didn't have one. So look how it printed it. The pages are so, I think the paper is too moist or something. Okay, so here is where we are. It's humid, so I don't know. Anyway, so we completed these, right? We completed these. We will continue with 6.3. These two are a review of these. There's a lot of overlapping. So we're gonna breeze through these two because they are the same with 6.1 and 6.1 and 6.2. And then we're gonna continue with chapter 6 and then continue back with a few things in chapter 5 that are not in chapter 6. So, but this will be a review of what we just did. But let's continue now with 6.3. Yes?
What is EOO?
It's written right here, every other odd.
Oh, so that's skipping one odd.
Yes, like 3, you start with 1, you skip 3, you do 5. You skip 7, you do 9. Yes. Very good. So, nothing basically in the next section from what we just looked at. Nothing, I shouldn't say nothing. There are a few things that we need to talk about. So, section 6.3, trig functions of angles. Trig functions of angles. First thing that I would like to do, talk about is sines. This is not sine, but the sign that plus or minus. Sines of trig functions in different quadrants. Because we have to establish that. That's very important. So let's look at the unit circle. And one more time, what do we measure on the x-axis?
Cosine.
Very good. What do we measure on the y-axis?
Sine.
Right, because it's always the opposite, right? If this is the angle, the opposite is measured on the y-axis. That's why sine is measured on the y-axis. If this is the angle, this is the adjacent. That's where cosine is. Good. So let's draw a unit circle again. So now I'm going to ask you basically, what are the signs of x and y in the first quadrant? What are the signs of x and y? Let's start with x first. So let's identify because it should be clear. Sine, cosine. So sine is first. Sine is measured on the y-axis. Yes, positive. Cosine is negative. Perfect. In the third quadrant, so this is the first, this is the second, this is the third, and this is the fourth. In the third quadrant, obviously, they are both negative. And in the fourth quadrant, sine is negative because it's below the x-axis, and cosine is positive. If I know and I remember the signs of sine and cosine, can I ask you the question, what is the sign of tangent in the second quadrant? Sine over cosine. Tangent is sine over cosine. What will be the sign of tangent in the second quadrant? Perfect. What will be the sign of cotangent in the third quadrant? Positive. What will be the sign of secant in the fourth quadrant? Secant is 1 over cosine. Since cosine is positive in the fourth quadrant, then secant will be positive. What is the sign of cotangent in the fourth quadrant? They're opposite signs. In cotangent, they're opposite signs. One is positive, one is negative. So what could be the sign in the fourth quadrant of cotangent? One is positive, one is negative, and cotangent is the ratio. Of course, negative, right? So now tangent and cotangent definitely have the same signs here, right? If tangent is positive, cotangent has to be positive because cotangent is 1 over tangent, right? Okay, so here tangent and cotangent have to be negative because one of these two is negative. Okay, so here's another way of remembering this. The top two quadrants have sign. What sign does sine have in the top quadrants? Correct, because it's measured on the y-axis. What is the sign of sine in the bottom quadrants? Right. What is the sign on the right-hand side for cosine? Yes. What is the sign on the other side for cosine? Right. And we will be able to establish any other function, right? Because we know the relationships between them. Correct? Okay. So that was one thing. We know what the reference angle is. The acute angle between the terminal side always formed with the x-axis. Terminal side and the x-axis. We know the fundamental. Yes. So let me write this again. Sine squared plus cosine squared equals 1. Very good. This is super important. So this is the first fundamental identity of trig. I would like you to tell me what happens if we decide to multiply or divide both sides by sine squared. So please divide both sides by sine squared and tell me what you get. So sine squared over sine squared, how much is that? 1 plus cosine squared over sine squared, how much is that? Very good. Cotangent squared. Perfect. And how much is 1 over sine squared? One?
No, 1 divided by.
Yes. Which function is 1 over sine? Cosecant. Very good. So this is the second super important trig identity. Fundamental. I would like us to come back to the first one, and I would like you this time to divide both sides by, what do you think? Squared. Very good. So please tell me what you get in order to establish the third one. Super important. What is it? Very good. Very good. So remember, all we did was we looked at the unit circle. We realized that sine squared plus cosine squared equals 1. And from here, we came up with the other two. So notice that cotangent and cosecant go together. 1 plus cotangent equals cosecant. 1 plus cotangent squared equals cosecant squared. And the other one, tangent squared plus 1 equals secant squared. You will see there is a very important relationship later on between tangent and secant in calculus. Okay, so now that's all I needed. And also I would like to show you how to calculate the area of a triangle if we are given two sides, adjacent sides, and the angle in between. Okay? So if we are given in this triangle, let's say the notation for the triangle, let me start from the beginning because I need to mention this now because this is very important. Okay. So this is a triangle. Any triangle. It doesn't have to be a right triangle. This is any triangle. And let's say I denote the vertices by A, B, and C. Now, when I identify the name for each side, it must be the opposite of the angle. So the angle is C, this leg must be denoted by lowercase c. The angle is A, this must be denoted by lowercase a. The angle is B, this must be denoted by lowercase b. So in this triangle, assuming I am given, we have given side A, side C, and angle B. So we are given this measure, and the angle in between. If that is the case, how do I determine the area of this triangle? Area of triangle ABC. Here's how I'm going to do it. I know that in order to find the area of a triangle, I have to have the base, the measure of the base, and I have to have the measure of the height. Anyone remembers the formula for the area of a triangle when we have the base and the height? Area of this triangle ABC must equal A multiplied by the height divided by 2. Perfect. A is okay. 2 is a number, but this I don't have. Let's go back to the right triangle on the left-hand side. I am given this angle B. This is given. And I'm given this side. Is there any way I can express the height, knowing that this is a right triangle, knowing that I have this angle, and knowing that I have the hypotenuse? Is there any way I can determine that height using a particular trig function to find the height, and knowing that I have the hypotenuse and knowing that I have this angle? Exactly. So please give me sine B. For some reason I wanted to write beta. Can anyone give us sine B? Let me just see how, oh, this one's B. H over C, very good. And now can anyone solve this equation for us for H? We want H from here. That's the only one I don't have. So H equals, what will you do to find H? Correct. So it's C sine B. That's all I need. And I got a new formula. But of course this works only, one more time, only if I'm given two adjacent sides and the angle in between. So then the area of the triangle ABC equals, can anyone dictate?
A times C sine B.
Since we have this right here, let's apply it in a problem. And then we'll go back to the rest of the type of problems here. And I cannot forget, I need to go back to the handout, this handout. This is from 5.2, but it's the same with 6.2. So I would like to go through these problems from our handout. Which handout is this? It's the additional suggested exercises for Math 151. Okay? So this. Because I don't want to forget this. Okay? So let's look at a problem in which we will find the area of a triangle given such and such. Okay, so let's say problem 55. Bless you. I put it on heat. For some reason, this room is either super hot or super. Find the area of a triangle with sides of length 10, 22, and the included angle 10 degrees. So this is problem 55 on page 460. Ready? Yes. So we have a triangle we are told that this is given to us 10, 22, and 10 degrees, and they're asking us to find the area of this triangle. How do I write the area of this triangle?
Area equals x times
10 times 22 times sine 10, 10 times 22 times sine the included between those two, divided by 2. And then I will look at the, and I brought it up, but I didn't start it. Here it is. So I simplify, so I have 5 times 22, 5 times 22, and sine 10, so sine 10, but I have to check, and since the software always goes back to the default, I'm sure it's back to radians, so I have to go to degrees, press enter, and enter. So I got 19.1. That's the area of this triangle, 19.1. Squared units, whatever the units are. We're not given any units. Yes. Yeah, 10 divided by 2 is 5, so I had 5 times 22 times sine. Any questions so far? So remember, this formula works only if I'm given two sides and the angle between those two sides. If I'm given two sides and this angle, I cannot use the formula.
Can you use like cosine?
No.
No. Right.
No. I must be given two sides and the angle included. Otherwise, I cannot find the area of the triangle. So now I want to go back to page 459. And, or we can start with this. So you can choose from here, or you can choose from 3 to 10. So I think we should start with this.
Okay.
Okay, so please choose whatever you want, because the rest you'll have to do on your own. So choose what you want. C, very good. So we have tangent negative 4 pi. Perfect. I have no idea what tangent negative 4 pi means. Yes, I do, but we have to show something here, right? Okay, so negative 4 pi, I know that 2 pi is a complete rotation. 4 pi will be 2 complete rotations, right? But since it's a negative number, I have to start here on the x-axis, but I have to go this way. Right? So all I'm asked to do here is to find tangent at 0 degrees or 0 radians. Right. So I know that tangent of 0 degrees is sine 0 degrees over cosine 0 degrees. And I know the coordinates of this point are 1, 0. So what is sine? Sine is measured on the
Y.
Good. So how much is sine? Very good. How much is cosine? So what is the answer? Okay. So you'll have to look at all the other ones, but please choose at least one more so we can move on. Seven pi over 2? Yes?
Yes.
Okay, very good. So we want to find sine 7 pi over 2. Any questions on the previous problem? Shane, are you okay? 7 pi over 2. Well, let's say I have no idea where this is. Here's how I count. 7 of 90 degrees. 1, 2, 3, 4, 5, 6, 7. So it starts on the x-axis And it does whatever, but it will have the terminal side here. Turns around 3 times.
How do you figure that again?
7 pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. Or you say 3, you take the integers out. 7 pi over 2 is 3 integers plus 1 pi over 2. Or you can split it in 2 pi's. You have several options. Good. So now I know the coordinates of this point. They are what? The coordinates of this point. 0, -1. So now I want to write the answer. Is sine the first coordinate or the second coordinate? Is it the x coordinate or the y coordinate? So the answer is, that's it. Okay, so this is your first assignment for Monday. Do we need anything else from here? Last one, very good. The 101 pi over 2?
Yeah.
Okay, very good. So we have tangent. So 101 pi over 2 is 50 and plus, right? 50 pi plus pi over 2. So 2 times 50 is 100. Remember our division. 2 times 50 pi is 100 pi plus another pi is 101. So these are all complete rotations because 550 pi divided by 2 pi is 25 complete rotations. Do we agree? So I start here on the x-axis and I go around the circle 25 times. When I'm done with the 25th, I still have to go 1 more pi over 2. So it ends here. It starts here, 25 times plus pi over 2. So what are the coordinates of this point? Good. I have no idea what tangent is there, but I'm going to write sine of this angle, 101 pi divided by 2, over cosine of this angle, whatever that is. So now sine at the top is 1. Cosine at that point is, and the answer is, thank you. Okay, can you manage the rest? Good. So please do that and ask questions on Monday. So now I'm back to page 459. And let's practice the reference angle. That's the key right now. Reference angle. Ready? Please choose from 3 to 10. 3 to 10 on page 459. Whatever you want. 6 it is. So find the reference angle for the given angle. Okay, so we have 99 degrees, we have negative 199 degrees, and we have 359 degrees. Perfect. There are 3 different angles. So let's look at the unit circle. I know that this point, this is 90 degrees. How much more do I go to the left? 9 more. So this must be 9 degrees. And where is the reference angle? So the reference angle is between the terminal side of this angle and the x-axis, because it has to be an angle less than 90 degrees. And it cannot be formed with the y-axis. It must be with the x-axis. Good. So can anyone tell us how much is the RA, reference angle?
81.
RA equals 81 degrees. From 90 degrees, you subtracted 9 to get 81. Very good. Negative, is this clear, everyone? Okay. Now, negative 199 degrees. I know that this is negative 180. So how much more do I go? 19. So this will be 19 degrees to get the whole angle of negative 199. Can anyone give us the RA? Very good. All RAs are positive. It's the acute angle formed between this and this. It will not have a sign. It will always be positive. Okay? So RA equals 19 degrees. The last one here. Let me see the time. Okay, still
Can
have
you do that one more time?
Yes, I have negative 199. So this is negative 180. Negative 180 and minus 19 will be negative 199. So I have to continue another 19. So this is the angle between this and this. This angle is negative 199. So that's why the RA is between the terminal side and the x-axis. The reference angle is 19 degrees. Better? Okay, the last one. I know that this is 360 degrees, right? But the angle is 359. So I have to stop short of 360. How many degrees? 1. So this is 1 degree. So can anyone give us the RA in this case? 1 degree. Okay, do we need anything else from 3 to 10?
Can we do like 8 or 10?
Please choose any. Which one? Okay, we want to look at 10. And we have 2.3 pi. We have 2.3. And we have negative 10 pi. Perfect. Okay, so I'm asked to find the reference angle for 2.3 pi. I have no idea what that is. I can just guess. Since pi is roughly 60 degrees, 60 times 2 would be 120 roughly, somewhere. Right? Because 2.3 times pi, roughly. So I look at a graphing calculator. Maybe let me do this here. So I put 2.3 multiplied by pi. By 180.
How did you get 180?
Pi.
Oh, okay.
Yeah, sorry. I was thinking of 1 radian, but that's here. 2.3 times. That's what I meant, not here. 2.3 radians means 2.3 times roughly 60 degrees. Not this one. Here I have to replace 1 pi by 180 degrees. Sorry about that. I looked at one thing and I was talking about the other. Okay, so I press enter now. So this is roughly 414. Oh, well, I shouldn't say roughly. It's just 414 degrees because we know that pi is 180. So then, coming back to my chart, so I have 360 is this. So 414 minus 360, that's 54. So I continue about 54 degrees. So can anyone give us the RA for 2.3 pi? 54 degrees. Now what if I'm asked to change this back into, since the angle is given in radians, the answer should be in radians. I know it's easier to just say, oh, okay, it's 54 degrees, but the answer has to be in radians. So 54 degrees, how do I change this? Remember, always write it on the side. Pi equals 180. If I want 1 degree, I have pi over 180. So it's 54 multiplied by pi over 180. So I'll put in the calculator and see what I get. So 54 times pi divided by 180. So I expect this, right? Because 57 degrees is 1 radian. So I expect this to be less than 1 radian. So it's 0.9425. So approximately 0.9425 radians. Although we don't have to write radians. Because when I say an angle has a measure of 0.9425, then it's assumed that it's radians. Okay.
Could you also write it like a 3 pi over 10?
Simplified, yes, and not approximated, yes. So this is 3 pi over 10. You simplified it? Excellent. So either like this or like this. Very good. So now 2.3 radians means 2.3 multiplied by approximately 57 degrees. Or I can write 2.3 in radians times 180 over pi. So let's see what that is. So I go to my calculator because I don't know, it's difficult to say, okay, we're on the circle, I have 2.3 radians. I know this is 57, another 57, and a little bit. So it should be in the second quadrant, but I don't know how much exactly. So 2.3 multiplied by 180 and divide by pi. So I got 132 roughly degrees, right? So then I will change it back. So 132, this is 90 degrees right here, right? This is 180 degrees, this is 90 degrees, and 132 is 40 more, so something like this. So this is the angle of 2.3 radians. Now, this is its RA, which is 180 degrees minus 132 degrees, which is, what, 48, approximately. The other way, not to, because this is an approximation here, the other way would be to say pi minus this angle, because I know I established it in the second quadrant. So if I subtract from 180 or from pi this angle, 2.3, pi is in radians, 2.3 is in radians, I will get radians with no approximation. If I keep it like this, it's no approximation. If you subtract it from pi, then you will have an approximation. So pi minus 2.3, I got approximately 0.8416, of course, radians. So what I did was I took pi and I subtracted 2.3. Okay. And I think there was a third one, wasn't it? Negative 10 pi. So negative 10 pi. So if I divide this by 2 pi, so 10 pi divided by 2 pi, this is 5 complete rotations. 10 pi divided by 1 complete rotation, I get 5. So this is in the negative. 1, 2, 3, 4, 5. So what is the RA for this point? The angle formed between its initial side and its terminal side. Absolutely. It ends and it starts at the same point. The RA has to be 0. Good. Now the next section is very important. So 11 through 34. Find the exact value of the trig function. This is the core of this portion of the material, this part of the material. So allow me to see again.